Assalamualaikum everyone. So we are from Group 8 and today we will be discussing about image sensor from Sony.
My name is Nofata Akila binti Amran. I'm a part of research and development team from Group 8 and today we are going to discuss about the main focus for CMOS, complementary metal oxide semiconductor. The main focus of CMOS lies in its ability to transfer electron to proton in digital processing, also used in camera digital, camera video digital and also in CCTV cameras. In the 1960s, the scientists in the Bell Lab create CCD, which is we call for charge coupled devices. It is such a groundbreaking because it can change from the light transform to the electrical impulses. CCD overtook all other digital camera. However, it has its own limitations such as it consumption excessive power and it has the requirement for mechanical shutters. In the 90s, Frank Wengles was invented CMOS. CMOS overtook the CCDs because it has less power consumption and other than that, it also more efficient than CCDs. In the 1999, which is the revolution for the smartphone, the Nokia and the iPhone has invented their more advanced CMOS technologies in the industry. Today, the smartphone account has take up more 70% in CMOS market. By 2014, the downfall for CCD. The CMOS has overtook the CCD such as in the manufacturing in Sony. CMOS has improved more in the image sensor company such as Sony because Sony rather take the CMOS rather than CCD. Thus, this is the end of the era for CCDs.
My name is Adrian Ilyasha bin Zulakba. I am part of the research and development team from Group 8, and today I'll be talking about CMOS fundamentals. And currently there's three main fundamentals, which includes the photo detection, the charge to voltage conversion, and also the signal processing. So for the fundamentals of CMOS sensors, so firstly the photo detection, which is basically how it detects light. So how a CMOS sensor detects light is through photodiodes. And as the lights hit these photodiodes, they create a charge, and this charge is proportional to the light intensity. And this correlates into our second fundamental, which is the charge to voltage conversion, which basically in each photodiodes there are presence of several transistors and they're in charge of amplifying and converting this charge into voltage. And then finally into our final fundamental, which is the signal processing. This is basically where all the voltage that was converted are transformed into digital signals. So basically, how does a CMOS sensor work? It all goes back into our fundamentals, which begins with photo detection. So as light is detected by the photodiodes, it accumulates charge, and this charge is also proportional to the light intensity, which basically means that the higher your charge, the more light intensity you're going to get. And eventually, this charge will then be converted into voltage by the transistors that are present in the photodiode. And this charge will also be amplified for a readout, which is in terms of rows and columns. And also, this voltage will then be processed into digital values, which will then be processed by the chip into an image. So that is basically how a CMOS sensor works. Alright, so on the topic of CMOS sensors, today I'll be showing you some of the technology developments by Sony on CMOS sensors, such as the very well-known CMOS sensors, which is known as the XMOS series. And also, Sony has developed the world's first stacked CMOS sensor series known as the XMO RS. And also lately, the latest version of Sony cameras, which is the A9 series, or specifically the A9 III, it features a CMOS sensor which is capable of shooting at 120 frames per second, whereas a normal camera averages at only 24 frames per second.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azam bin Sohaimi and I will discussing about the business product based on technology. Sony Semiconductor Solutions Corporations (SSS) always keep innovating on the image sensor after the replacing of the CCD with the CMOS. Sony Semiconductor Solutions is advancing more development of the back illuminated and stacked CMOS image sensor. In the front illuminated CMOS image sensor, there is a wiring that connected to the various elements of the light incident surface. This increasing the sensitivity due to blocking the racing of the photodiode. Nowadays, pixels are getting finer. The finer the pixels, the greater the reduction in the sensitivity. To serve it, a back illuminated CMOS image sensor is developed with the substrate bonding technology to flip the photodiode substrate. High precision grinding technology to control the thickness of the substrate. and technology to suppress the noise during the grinding process. Sony is the first company in the world to commercialize a back-illuminated CMOS image sensor, which has become the standard structure for CMOS image sensor. The advantage of the back-illuminated technology in the Sony CMOS image sensor. Firstly, the higher sensitivity. Back-illuminated technology allows more light to reach the light-sensitive pixel of the sensor since the wiring and the transistor are positioned behind the photodiode. This configured result in improved sensitivity to light, especially in the low light conditions, leading to brighter and clear image with reduced noise. Secondly, better wiring layout improve image quality. With the wiring and circuitry positioned behind the photodiode, there is less interference with the incoming light. This optimized layout minimizes light obstruction and shadowing, resulting in a better image quality with the enhanced sharpness, contrast, and color accuracy. Finally, it allows high-speed recording. Back-illuminated sensors are capable of capturing image at a high frame rate, making them suitable of applications that require fast-moving subject to the capture with precision, such as sport photography or videography. The increasing sensitivity and improved signal-to-noise ratio contribute to smoother and more detailed high-speed recording. The second technology of the CMOS image sensor is stacked CMOS image sensor. Back-illuminated CMOS image sensor require supporting substrate to ensure the mechanical strength, but stacked CMOS image sensor use a circuit chip that has thousands of electronic connections between the pixel chip and circuit chip. It rearranges the pixels and circuit sections, which are placed from the same silicon chip to separate into the two layers. This allows for optimal manufacturing process, and high-capacity logic circuits can be fitted into the smaller area. Finally, the advantage of the stacked CMOS image sensor is small size, high functionality, and it can capture a clear photo against a strong backlight.
I'm Shazliana.
And I'm Ifa. Now we will be discussing about the manufactured products that related to the optical materials.
And now I will show you how CMOS affect the image produced by the camera. From these two images, you can see CMOS helps in reducing overexposure and underexposure of the image in a combination of bright and dim illuminations. Plus, CMOS also helps in reducing the low noise image in a low light condition.
Actually, I believe that some of you guys are wondering about the feedback regarding to the image sensor by Sony. Don't worry, because most of the feedbacks are very positive. If you guys want to know, one of the feedback is here, and another one is here.
Sony is a giant in the industry of CMOS image sensor, and with big names in the game such as Samsung, Canon, and Panasonic. According to your research, in 2022, the CMOS image sensor industry is a 21.29 billion business, and with Sony taking a 42% dominance in the market, they are no doubt the biggest winner. If we dive into the breakdown of where all this image sensor is utilized, we found a great range of applications, from commercial camera devices to automotives to medical purposes, security, and even aerospace and defense. All requires a sophisticated artificial eye to function properly. As expected, commercial mobile devices took the biggest bite out of this market, as mobile phones become a more and more normalized product integrating into our daily lives, and phone camera abilities become an increasingly important feature to take into consideration when buying a phone. A staggering 63% of all the CMOS image sensor manufactured in 2022 is assembled into one of these mobile devices' camera system. This is when the greatest collaboration in the mobile phone industry is unveiled. Sony has been anonymously supporting the camera module system of all the big names in the game. From best value phones to high-end smartphones, Sony is no stranger to them. Then it is with no doubts the biggest buyer of Sony is also the biggest smartphone brand, Apple. Apple has exclusively only partnered with Sony since the early days of iPhone 4S to produce all their image sensor technologies, and up until the latest iPhone 15 Pro series. It is always rare that Apple reveal which company manufacture the components of their phones, but the CEO of Apple, Tim Cook, unprecedentedly revealed their long-term partnership with Sony in a very public visit to Sony HQ in Japan, just proving how valuable Sony is to the company of Apple.